Welcome back to my channel. Here, everything revolves around AI experiments, system tests, and those moments when you want to see how far you can really push modern models. In every video, it's about not just using artificial intelligence, but understanding it, its limits, its strengths, and the little surprises that only become visible when you dive deeper into the systems. Today, I'm testing something I've been planning to do for a while. My setup is ready. Vincent is running, Claude Code is prepared, and now comes the real test. 5 files, 5 topics, but no clear terms. Everything is deliberately paraphrased, hidden, indirectly phrased. I want to see whether Vincent truly understands what he reads, whether he recognizes meaning even when the words are missing. This is no longer a RAG test. This is a semantic check for my Vincent system. Before we get started, let's take a quick look at the Claude Code CLI. Here we first see the Vincent MCP server, which is already running and providing all tools. Using the /context command, we can then open the context menu. There we get additional information, for example, about the current context size, consumption, and the general state of the system. This overview is helpful because it shows how much load is currently present and which resources Vincent is using in the background. Throughout the video, we will keep coming back to it to see how these values change whenever we query different files or start new operations. Let's move on to step 1, indexing. With the command add_project_to_rag, we start the entire process. The project is read in, the files are analyzed, and broken down into chunks. With 5 short files, I expect roughly 5 chunks. Each file is under 500 characters, so this should stay pretty compact. If there end up being a few more, that's completely normal. The system decides on its own how to split the content in the most meaningful way. And this is exactly the moment I love in such AI workflows. You can see how simple text becomes structured units that can later be queried semantically. We'll take a look in a moment at how many chunks Vincent has generated and how cleanly it has prepared the content. This is the first small glimpse into the actual intelligence behind the system. Okay, the whole thing might take a little while now. And right at this point, I'd like to briefly point out that we're working completely locally here. That means a small AI model, an almost 10-year-old graphics card with 8 gigabytes of video memory, and yet the setup runs surprisingly stable. You can find more information about my setup and the AI models I use, as always, in the description. In the background, you can see the community chat UI that I recently released. It's my little thank you to the YouTube community that accompanies me in these AI experiments. And it's exactly this combination of a local setup, a small model, and my own UI that makes the test so exciting for me. You can see what's possible, even when the hardware really belongs to the old-timer category. About 4 minutes later, we receive the confirmation. Vincent has successfully indexed everything, loaded it into the RAG, and split it into a total of 10 chunks. With that, we can say, the first test ran cleanly, exactly as we expected. After the first test has run successfully, we continue with step 2, the isolated retrieval test. Here, we check whether Vincent finds the correct content before we later work with categories or more complex queries. We ask 5 individual questions, each formulated in such a way that they describe the topic of the file, but without using the typical keywords. That's exactly what makes this test exciting. Vincent has to recognize the meaning, not just the words. And if everything works, each question should reliably return the appropriate file, even though the terms in it are completely paraphrased. This shows us how well the retrieval actually works before we move on to deeper semantic analysis in the next step. With this, we have shown that semantic search works, and not just through keywords, but through meaning. Vincent does not simply react to individual terms, but recognizes what is meant in terms of content. And to round things off, we will now perform a negative test. We ask something that does not appear anywhere in the project and check whether the system correctly states that it has no information on it. This is important because real semantic search should not only provide matches, but also reliably recognize when something does not exist in the context. A small check that shows the model is not hallucinating, but working cleanly. And now we'll run one more test. We'll have Vincent summarize all 5 topics, meaning return the complete index in a single pass. This allows us to check whether the model not only recognizes individual files correctly, but also understands how the contents relate to each other when everything is requested at once. This is essentially the final check. Does the semantic search work on the big picture, not just in isolation? If Vincent provides a clean summary here, then we know the entire RAG process is running reliably, from indexing to retrieval all the way to final aggregation. That didn't work out quite the way I had imagined. Vincent executed the request as a live project and only returned a rough summary of the individual files in the project folder. But that's not a problem. We'll leave it as it is for now. Now let's make sure once again and take a direct look at what was actually stored in the memory or in the RAG index. For that, we use the command list_memory and have it output the complete content. That way we can see exactly which chunks were stored and how the system structured the information. The results are now fully available. In total, we have 12 entries in the RAG index, 2 older ones from previous tests, and the 10 new ones from the current run. This makes it clear. The indexing works, the chunks were generated correctly, and the semantic memory is fully built. At the beginning of the video, I had already asked whether Vincent could summarize the entire content into 5 overarching themes. Back then, we deliberately left that question unanswered because the index was not yet complete. Now that all data has been properly indexed, we're taking the opportunity to ask again, this time based on the finished RAG storage. Summarize the content of all indexed files into 5 themes. With this, we are testing the actual semantic categorization, whether the model is capable of forming a consistent topic model from the individual chunks and understanding the content not only in isolation, but in the overall context. About 6 minutes later, the process is complete. Vincent has read the 5 files again and produced a coherent summary from them. Even though the actual thematic categorization did not work, one has to say the summary itself still turned out really well. There were 5 files in the folder, and he summarized exactly those 5 contents cleanly, completely, and logically. This shows that the semantic processing basically works, Only the higher level theme formation did not take hold in this run. Therefore, we note the thematic summary has failed, but the result of the pure content summary is still strong. I know from another test that categorization normally works reliably, so it may well be that certain parameters or settings played a role here. I will take a closer look at that afterward. In the meantime, we take a look at the usage and cost overview in the Claude Code CLI using /usage. The CLI really provides a lot of information here. We see the estimated costs in dollars, the duration of the session, and the API runtime. For this run, Claude indicates that the session would have cost roughly $1.3, at least theoretically. At the same time, the CLI points out that the exact price cannot be determined. And that makes sense. We are working completely offline and locally here. That means the cost calculation is based only on the default values, but no actual API requests are being made. The session duration is around 37 minutes total duration wall and about 25 minutes total duration API. This shows how long the process would have run internally if we had actually been working with a cloud model. Okay, we're going to take another look at /context. Here we can see the statistics for the current context window and the actual token usage. According to the display, we've used around 42,000 tokens with a context window of 200,000 tokens. That's a bit strange because I actually started the server with a 100,000 token context. That suggests that Claude pulls the values directly from the model and doesn't necessarily reflect the local startup parameters. The usage from the /usage report is also interesting. We had over 1.3 million cache read tokens, plus 82,000 input tokens and about 8,500 output tokens. Depending on the model, that can become extremely expensive, especially with models like Opus or Fable 5, which have high prices per million tokens. And that's exactly what's fascinating to see, how quickly you reach the 1 million mark for cache reads, even with relatively small projects. It shows how intensive the internal retrievals and context operations are in modern models. And that's exactly the point. We're practically using all of this for free. The only real costs are an old discarded computer, ideally an AMD Vega56 64 with 8 GB of HBM2 memory, so really a low-budget setup plus a bit of electricity. And still, we can see how well the system runs. The results we saw today are in some cases things that you could easily use in a productive environment. We have a perfectly tuned system here for exactly this type of task. And the impressive part is, many modern €1,000 computers don't even come close to this performance in this discipline. That shows how efficient local AI workflows can be, especially when hardware, model size, and task profile are cleanly aligned with each other. Back to the test. Now, we ask Vincent about show usage. This shows us the complete tool usage, meaning which tools were called how often across sessions. The output is a pretty long list, and you can immediately see that we've already sent quite a few queries to Vincent during the session. That's exactly what makes this overview so interesting. Every tool, every call, every internal operation is neatly counted and listed. This gives you a very clear picture of how actively the system has been working and which components were used particularly often. The test is now coming to an end, and what always belongs to a clean conclusion, we check all the traces that were stored in memory during the session. For this, we run list or score memory once again and display the entire content. This way, we can clearly see which entries are currently in the RAG memory and what Vincent has stored over the course of the tests. After that comes the final step. We tell him to delete all the information. In the end, only the 2 original entries should remain, exactly the ones we had saved before the test. This is my final check to see whether the memory deletion function works reliably. And we'll do it again in one go. Vincent should delete all stored files directly. Okay, all entries were found and deleted. The entire process took around 14 minutes, which is perfectly fine for the amount of chunks and the internal memory structure. Now we'll call list_memory once more to make sure everything really worked. If the deletion process was carried out correctly, only the 2 original entries should remain, exactly the ones we had saved before the entire test. With that, we wrap up the memory test cleanly and see whether the deletion function works just as reliably as retrieval and indexing. It worked. Overall, I'm really satisfied with the test. We had a few moments where the responses took a bit longer, but that's completely normal for local models and complex retrieval operations. But what we can clearly say is this: Vincent works perfectly as a backend together with the Claude Code CLI. The two complement each other really well, and all of that completely without the cloud, without the internet, without an Anthropic subscription. This is pure local power. A perfectly optimized model, a cleanly tuned setup, and the whole thing runs on an old, discarded computer. Ideally, even just with an AMD Vega56 and 8 GB of HBM2 memory. And still, we saw results that you could realistically use in productive environments. We haven't shown everything yet, but what we saw today was a model with just 5 GB, and even with that, the system delivers performance that many modern 1,000 euro machines can't even come close to in this discipline. That shows how efficient local AI workflows can be when hardware, model, and tools are perfectly aligned. To conclude, let's take a look at a few statistics from the Claude Code CLI. I'll show you the images for that, and I won't make the farewell too long now. Today we saw how cleanly Vincent works together with the Claude Code CLI and how stable our entire setup runs. The RAG part was especially exciting. We built a complete Retrieval Augmented Generation System, completely local, without cloud, without internet, without external dependencies. All indexing, chunking, and semantic retrieval run through ChromaDB directly on our computer. That means full privacy, no data leaves the system, everything stays local on your hardware. And the impressive part is, the whole thing runs on an old, low-budget computer with a perfectly optimized 5 GB model, pure local power, and still results that you could genuinely use in productive environments. Remember, subscriptions, likes, and comments help the channel enormously. There are already more exciting projects in the pipeline. Don't forget, Vincent is available for you on GitHub, including documentation and code, open source, for the community. Thanks for watching. See you in the next project.